number 3. So a square root is like what kind of power? 1/2. So inside here we have an x squared times a cube root of x would be x to the 1/3. When you multiply these x's, what do you do with their exponents? Add them. So 2 plus 1/3 would be 7/3. And then if it's a power to a power, so it's x to the 7/6.
I did not even do it that way when I got my answer.
Did you do the 1/2 to each of them first?
Yeah.
That works too.
I don't know what I did. Because then I got x times x to the 1/6.
Mhm.
And it gave me x.
So number 4, we have the cube root of z to the 4th times the square root of z. So the cube root of z to the 4th would be z to the 4/3. And the square root of z is z to the 1/2. So when you multiply, what do we do with the exponents? Add them. And so this would give us z to the 11/6 power. Then the next type of question that will be on there, a domain question. So basically if it's an even radical, like number 5, whatever is under, so the 9x plus 18 has to be greater than or equal to 0. If you solve that, you get x is greater than or equal to -2. So your domain is -2 to infinity. And number 6, if it's an odd radical, what is your domain automatically? We don't have to solve anything. So do you guys understand the difference between questions 5 and 6? Basically, if it's an even index, so square root, 4th root, 6th root, you have to do greater than 0. If it's an odd, it can be
Wait,
infinity.
I'm confused on how you work over to find out.
Okay. So you just have to take what's under the radical. So we get to ignore the -2 in front.
Oh, okay, I get it now.
Okay.
That's what that would do.
So do you just divide the 9 by 18?
Yeah. Subtract over the 18 and divide by 9.
Oh, yeah.
All right. So then the next section, 7 through 14, we solved all of these radical problems. So on those problems, you have to remember to always isolate your radical first, and you have to check your answers.
Did you number 10?
Yes.
I didn't even check my answers. I just wrote them down.
So x to the 2/3 means you have the cube root of x squared plus 2 times x to the 1/3. X to the 1/3, that's like the cube root of x. I'm going to subtract over that 3. So this is different than the other problems because I have more than one radical. To get rid of a radical, we have to have it on the side by itself, but that's difficult since 2 things have a radical and 1 doesn't. However, this is like a quadratic. Because that's a squared, we can do the box method here. So we'll put a cube root of x in each of them. Then multiply to -3 and add to +2. +3, -1. So if you set each of those equal to 0, and then how do we get x by itself? Cube each side. So we get x to equal a -27 and a +1. And then you have to check them by putting them back into the original and making sure they work, which they do.
I get good stuff. So I didn't cross out.
I think number 9 has an answer that doesn't work on it.
Yeah.
negative 2 doesn't
Yeah, the
work.
negative 2 doesn't work, then 1 does, though.
Okay, do I need to work out 7, 8, or 9?
No.
What about problem 11? That's another one that is
Yes.
a little bit different.
Yep.
Yeah, do that one.
Okay, so there are two ways of doing this one. In answering questions, most people rewrote it. What does a negative exponent do?
Flip it.
So the negative 2 is just on the x, so the 6 stays, but the x would go down to the bottom. X to the negative 1 would be 1 over x. So if I want to get rid of the fractions, what would we have to do? So those cancel and I just get a 6. X squared divided by x would just give me 1 times x. And then 2x.
Oh, you can multiply that squared by everything.
So what I would do at this point is put everything on the same side. So now this is really just a box method problem. So I need two numbers that multiply to a negative 12 and add to a negative 1. Negative 4, positive 3. Then what do we do?
7 to 0.
So we get negative 3 halves and positive 2. And then you check, which just means plug it back into the original, and both of those do work.
That's great.
12, 13, 14, can you talk about any of those?
Can you do 12? Yeah, can
Yeah.
you do 12? I have it down, but I don't know.
It's a little weird.
Yeah.
Okay, so we always isolate our radical first, and we have just one radical on the side. So then, to get rid of a square root, we would square. What you do to one side, you have to do to the other. So this square root and the square cancel. And over here, this square root and the square cancel. But I still have a square root, so we have to square again. So we square each side of the equal sign. So over here, 2 squared is 4. The square root of 7x plus 2 squared, so the square root would drop. And then what do we have to do on the right? FOIL. There's like 2 of those. So you get 9x squared plus 6x and plus 6x. We distribute the 4. And we need to set it equal to 0. So subtract over the 28x. Subtract over the 8. So now we can do box method. So those multiply to negative 36 and add to negative 16. Mhm. Do I need to show how I got those?
Why did I get a positive 2 9s?
Did you have 9x plus 2?
No, I don't know why I wrote minus though, because on my like box method I literally have a positive 2.
See, I have negative 9x minus 2, but like it equals, I don't know actually what I did. Why do I have like negative 9?
Okay.
Oh, okay.
Alright, what about 13 or 14?
I got a weird answer for 14.
Okay.
82 over 3? Yeah, that's very
Yeah, that's
easy.
what I-
Oh, okay then.
Does anybody want me to work it?
No. Well, I was gonna say, I understand it, obviously, but I didn't think I did.
Yeah, you just have to make sure that you get the radical by sum first. So just subtract over your 4, and then to cancel it 4 through, you have to take everything to the 4th power. So then add over your 1, and are we good with 13?
Yeah.
Okay. Plus or minus 125? Okay. 15, how do you decide if a graph is 1-to-1?
Yeah, I don't know. I don't have a calculator.
Horizontal line. Yeah.
It is that?
Yes, so you can basically just graph it and see. So that one, does it pass the horizontal line test?
No.
No, so it is not 1-to-1, which means we can't find the inverse. Okay, what about the graphs on 16?
Are you just supposed to, I'm confused.
On 16?
Were you literally just supposed to put it in?
And sketch what the graph looks
Or, no, you were supposed to do
Do
the
one and
XYT
negative one.
chart.
Yeah.
Right? Yeah, no. I just put it in the calculator.
If I put this on the test, I will say a minimum of 3 exact points.
Oh no.
So what 3 points do we plug in?
0, 1,
0, 1, and negative
Mhm.
1.
So 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first is 2.
I didn't do that one. Because I just thought I was like, oh, my graph looks like that. Yeah,
So just make sure that on the test you were showing the exact points. I'm going to go ahead and do h of x on the same graph, because h of x is 2 to the x minus 3. What would the minus 3 do? When you move up or down, I would like for you to draw in the asymptote. So that would move down 3. And then you can just take each of those points down.
Wow, I can't believe I did that. That's kind of funny.
Well, I thought it meant to just
I thought it was
sketch
like,
it.
I thought it meant
Like
plugging
plot
in
it
and
and then
sketch
sketch it, and then I was like, why would she have a question mark? Just
That's what I did. That's what I did. I wrote myself a note though, show exact points on the test.
Good. Do you want me to go ahead and do the 1/2 to the x as well? It'll only take a second. Okay, what is 1/2 to the negative 1 power?
Just
2. Negative exponents flip it. 1/2 to the 0
1.
and 1/2 to the first is 1/2. So there's,
Yeah, I mean, my stuff looks like that.
you just didn't have the exact one. And then the other one of those, we had j of x is 1/2 to the x plus 2. So what would the plus 2 do?
move it left 2.
Left 2.
So why is one of them dotted and one of them ain't?
Oh, just because I was lazy and didn't want to draw 4 separate graphs. I just didn't know that was going on. I was just trying to show the difference between the two graphs that I drew. Is that one okay? Then we got into finding inverses. So I put 3 of those on there, and I'm guessing we probably should work out a couple of them.
Yeah. Yep, especially the domain.
Yeah, the domain.
Domain and range. Okay, let's do 17 and then one of the other 2.
Alright, sounds good.
Okay, so first step on these is what?
Next.
Yes, instead of f of x, we write a y, and then we're going to switch x and y. So it'll be x equals 4y
And
minus
then
y.
you solve for y in case you don't ever say that again, right?
So if we add over the 5, divide by 4. At the very end, instead of y, we write f inverse of x.
Oh, shit.
And so we get x plus 5 over 4.
Wait, is this the one where you have the x and y and the divide for x?
Okay, well, good job to me, because I got that.
I
but don't know how to
was
do the
not.
rest.
Sorry.
Yeah, I got that.
Okay. So then I asked for domain and range of both the function and the inverse. But we're really not finding 4 different things because the domain of the function is the same.
It's the same as the range of the inverse.
Okay. So ranges are hard to find. So instead we're just going to find domain. So if I look at the original, there is no fraction, there is no square root. So what can x be? Anything. So it's negative infinity to positive infinity. It's just a line.
Wait, how did you just figure that out?
Because there's an m something.
I don't understand.
Basically, there's nothing x can't be. When I'm talking about what x can't be, if we have a fraction, the bottom can't be 0. And if we have a radical,
I know, I'm good.
or you can always graph it on your graphing calculator too, and you'll see that it keeps going in both directions. Now for the range of the function, we'll just look at the inverse and find its domain. It's a fraction, so we know in a fraction the bottom can't be 0. Does 4 ever equal 0? No, so it is also everything.
Well, that was easy.
Good.
Yeah, no, I don't know how to do it, like, dang.
All right, would you like for me to work 18 or 19?
Yeah, can you?
Wait, I think I have both of them done. I don't know if I did them right.
Okay.
Can we go with 18?
Yep. So first step, we change f of x to a y. Then we have to switch x and y. So it becomes x equals y plus 2 over y minus 1. So now we try to solve for y, so we usually just multiply to get rid of the fraction. So I get xy minus x equals y plus 2. I'm trying to solve for y, and I have 2 of them, so what should we do?
Oh, but you can factor y?
Yeah, let's get the y's on the same side before we factor it in. So if we add x and subtract y, we get xy minus y equals 2 plus x. So now, what can I factor out over here? Y. And that leaves us with x minus 1. So then to get y by itself, we have to divide. So we get 2 plus x over x minus 1. So that is our inverse. So domain of the function and range of the inverse. If I look at my original, the denominator can't be 0, so x can't be
Negative
1. Negative infinity to 1.
Oh, and one, right. I got it right.
Okay, range of the function and domain of the inverse. So we go to our inverse. What can x not be? 1.
Is it gonna be the same? Or was
No, that was just a fluke.
What are we doing here later, Dave?
Oh, I didn't put both of them down because I thought they were the same, so I didn't ACT.
Oh, they are the same this time, but they're not always.
Or what?
Yeah, I got to question 23.
Oh, what's it?
Because this is you when you're taking it.
Okay, do we need to do problem 19? No.
Can you tell what do you know what the answer is though?
Your inverse is 1 minus 2x over x. And domain of the function is negative infinity to negative 2, union negative 2 to infinity. The range of the the range of the function and domain of the inverse is negative infinity to 0, union 0 to infinity.
I forgot to put the
I'm telling which one was which. Okay, then we get into the exponential equations. So let's do this page first, 20 through 23. Any of those you would like for me to work?
22.
Uh-huh.
I think I got 2 answers.
No, I think I did get it, but I don't understand what I'm doing.
Okay, so there's a couple ways of doing this. I noticed a couple people that squared first to cancel the square root, and that is fine. Other people just changed that square root to what kind of power? So either way, we're going to get to the same point here in a second. All right. So now we have a common base, which means the exponents are equal. This is like a quadratic, so we can set it equal to 0. But I don't want to try to do a box method with a fraction. How could I get rid of that 1/2? Or let's just multiply everything by 2. You're trying to write it with a negative exponent. But if I just want to cancel it, we could just multiply by 2. So we get 8x squared plus 2x minus 1 equals 0. So now it's a quadratic, we can do box method. So two things that multiply to a negative 8 and add to a positive 2. Positive 4, negative 2. So then we set those equal to 0. And get it 1/4 and negative 1/2. And you could always check these. Your answers should work, but we can always plug them back in the original if we want to check. Do we need to look at 20, 21, or 23? Mm-hmm. 7 equal to each other.
Oh yeah, that's what I meant.
Yeah.
What did you get for that answer?
I haven't done anything.
I was just.
You
my
should
brain
get-
yesterday.
Problem number 20 is negative 1/2. 21 is negative 16 over 9. And 23 is 1/2.
On 20, I got 0, but I don't.
Okay, let's look at it. So we have to get a common base. What can I change 8 to?
2
And 4 is 2 squared. All right, so then power to a power, we multiply. So 3 times negative x would be negative 3x. When I multiply these, what do we do with their exponents? Mhm. So now we have the same base on each side. So we can set those equal to each other.
So they can have 1 or 2 answers.
Yes. And then we get this one.
If you have box method or something.
Yeah, basically,
The only time you have 2 answers, right?
yeah, so if you look like 23, one of your exponents had an x squared, that's why it got 2.
23.
Sorry, 22.
I was saying, I only got 1 answer.
But all these others just have an x to the first, so we only got one answer. Okay, let's flip to
Can
the
you
back.
say what the answer for 21 is?
Sure. 21 is negative 16 over 9.
And then number 23.
1/2.
Okay.
So these were a little bit uglier. 24 through 27, what do you want me to work out?
I don't know.
24,
Can
I
we do
did
24 and 27?
Maybe I should tell you the answers to the others and see if we make those.
I didn't know. I tried to do this, but I got lost by years.
The fractions make it a lot
That's why I was.
harder.
Are the fractions gonna be on the test?
I mean, I could potentially. I probably wouldn't do a ton of them like that.
I don't think you should do any of them like that.
So, 2/3 I can't break down. So I know this one has to stay. But over here, when I think about 81, that's the same as what?
3 to the 4?
Mm-hmm. And 16 is the same as 2 to the 4. So I can write this as a base of 2/3. But you'll notice I had the 16 on the bottom. So if I need to flip it, what kind of exponent should that be? Negative 4. Is everybody with me on that one?
No, like it makes sense. I feel like I just, like I wouldn't think to put the negative 4 in the.
Inside there?
Yeah. But it makes sense, like I get why.
Okay. So then, with these exponents, you have a power to a power, so you multiply those. So we get negative 4x minus 4. So now they each have a base of 2/3, so now the exponents are equal to each other. So we add over the 4x, add over the 1, and we get negative 3/5. And if you're ever not sure if you did it right, you can always plug it back in and check it too. So the next 3 are inequalities. 25, you should get negative infinity to 4/9. Do we need to look at that?
Alright. Wait, what was the answer?
Negative infinity to positive 4/9.
I got x's less than or equal to 4 and 9.
Okay, I just wrote that as an interval.
Yeah.
Do we have to have this in?
I would probably
Yeah,
ask
that's
for it on
how-
the test, so
That's
it's
how
like
I had it.
everything's smaller than 4/9.
So do we have to write it as the infinity thing?
Or-
So if we put that, it's wrong.
Oh, it'd probably be like a half point for not writing the interval.
couple of points. I might forget.
Does you have intervals for all the
There's
ones
no
that are
inequalities.
Yes, inequalities give you intervals. 26, you should get negative infinity to negative 3.
I started that one, but I didn't finish it yet.
Okay.
For the, like the first part of it, I changed like the 5 into like a fraction.
Mhm.
But since the other one is 1/5, can I just like flip it since it already has a negative x?
Yes, so we have a couple options for how to work this problem. A cube root is like what kind of exponent? 1/3. If I wanted to write this 1/5 as the same base, that would be 5 to the what power?
-1. My brain is like about to be dead.
So then a power to a power we can multiply, so we get 5 to the negative 1/3 x is less than 5 to the negative x minus 2. So since it's the same base on each side, we can drop it. So if I add over my x, divide by 2/3, and you get, oh, not negative 1. X is less than negative 3. So that would be everything smaller than negative 3. So 27, we already asked about that, so we'll look at, are we okay with 26?
Hang on. You can move on. I'm just trying to think.
Okay, you sure?
Yeah. I'll ask you in a second if I still don't have it.
Okay. So we have a 5/3 to the x. So again, we need to get a common base. I can't really break down 5/3, so I'm just going to leave that alone. 9 over 25. I could write that as a 5/3. But first of all, I notice it's flipped, so it would have to be a negative exponent. And what number do I put that? 2. 3 squared is 9, 5 squared is 25. So then we get 5/3 to the x is greater than or equal to 5/3 to the negative 2 plus 10x. So then you can drop the base.
Wait, why does your board have a yellow line around it?
Because I'm recording.
Oh.
So if I subtract over my 10x, divide by negative 9. If you divide by a negative, what happens to the inequality? So less than or equal to 2/9 would be negative infinity. Positive 2/9, so an equal to says bracket.
What number is this one?
That was 27.
That's 27?
Mm-hmm. So the last ones are interest. I told you guys that I would give you the formulas for the test. You just have to be able to use them. So if it's okay with you, I'm going to run through those and make sure we're okay with that.
I think I'm good with it. I just
Didn't get it done.
didn't.
All right, so an investor has $40,000 to be invested for 3 years. So what is the 40,000? P. It's what we have right now. And so the 3 years is the time. All right, then we have to do each of these plans. So we're going to calculate two things. And plan E, or plan E, oh my, plan A, 0.5%. So what would I use for the rate? 0.005, because you have to move it back 2. Compounded quarterly, so my N is 4. So then the formula is so I don't know A. P is 40,000. 1 plus R 0.005 over N, which is 4, to the 4 times 3 power. And so then if you remember when we did these, we just put everything in our calculator at once to try to get the final answer.
I couldn't figure out what the 4, where'd you 4?
Because it was compounded quarterly, so that's 4 times a year.
Oh, I was trying to figure that out.
And since it is money, we will round to the nearest cent. So we get $40,604.14 for Plan A. Plan B is 0.4%, so the rate is 0.004, compounded continuously. So that's the second step. Yeah. So the P is 40,000. E to the 0.004 times 3 power. So we're trying to figure out which one would be a better option. If you are investing your money, you want as much as you can get at the end, so we want to go with
Plan A.
Plan A. It's going to give us more money.
I would rather just work a second job because $604 is not that much. Okay, this is free.
All right. Problem 29 is just a little bit different. It says in 72 months. Remember, the time has to be in years. So how do you change that into years? So the time is 6 years. You must have $12,000. So $12,000 is not right now. It's at some point in the future. So that is the A, the ending amount. What amount invested today? So I'm looking for my P. At 1.7%. So the rate would be 0.017. Compounded monthly, so N is 12. So if we plug in, we have 12,000 equals P times 1 plus 0.017 over 12. The 12 times 6 power. So if you want to get P, all you really have to do is divide over that entire parentheses. So you could just type in 12,000 divided by all of that. You get $10,837.14. So our function,
I thought we did 18.
I think we
She
did
did
8.
all the other ones,
We did,
but
so
She didn't do not do, she told us the answer.
So f of x, we change to y. Switch x and y. So if I want to solve for y, we can multiply over the y plus 2. What'd you guys do here? Did you distribute the x or divide by it?
Divide by
Got it, got it.
You can distribute it as well. It works both ways. So if you had this and divided by x, you get y plus 2 equals 1 over x. So you get y is 1 over x with a minus 2 on the end. If you distributed first, you will get 1 minus 2x over x. So either of those answers, they're equivalent for your inverse.
Yeah, that's what I got.
Okay. So domain of the function and range of the inverse. If I look at the original function, what can x not be? Negative 2. So we have negative infinity to negative 2, union negative 2 to infinity. Range of the function is the same as the domain of the inverse. So if I look at my inverse, what can x not be?